Welcome to the next session of our full day of DevDays talks. I'm going to give the word to Simone in 10 seconds. My name is Martina. I'm your moderator for today. And if you have any questions, I think it will be very interactive, so it will be at any time. Then I'll reach out to you with a mic so everyone can hear your question. And for the rest, I'll leave it all up to Simone to tell you what she's going to do here.
Thank you. Welcome, everyone, to this FHIR Shorthand tutorial. We actually have two sessions on this topic. The first one is labeled as a tutorial, and the next one after the break is labeled as hands-on. However, my personal opinion is that there is no better way to teach what's basically a programming language than to actually do it. So I'm going to spare you the PowerPoint slides, and I would like to get right into the hands-on session. I want to do exercises for the whole 2 sessions. So we use the first session to talk a little bit about what it's actually all about and to get everyone set up with the tools you need to participate in the hands-on session. And once we've done that, we're going to start right with the exercises. Then instead of PowerPoint slides or documentation, I want you to take home at the end of these 2 sessions code that you've written and that you can use to build on top of. So that's why this is going to be mostly a hands-on session. First of all, a few words about me. My name is Simone Heckmann. I'm a CEO of a small company in Germany that provides FHIR training and consultancy since 2016. I'm also chair of the technical committee for FHIR at HR7 Germany and member of the Digital Health Council in Germany, which is a council that basically consults with the government as far as healthcare interoperability legislation is concerned. Again, the objectives of this sessions, or basically the next 2 sessions, is to get everything set up, to have the tools ready so you can start right away creating FHIR Shorthand code. And then we go and fry some fish, basically write our own FHIR Shorthand code and create our first FHIR resources. Quick disclaimer, this session is not going to be about how to build an implementation guide. I know that FHIR Shorthand and the IG Publisher are often used in conjunction, but they are 2 separate tools that are well integrated, but still separate, and we're only going to talk about the FHIR Shorthand part of the equation. There's another tutorial out there. I think it's already happened yesterday. I think Ward gave an introduction into FHIR profiling, where he also covered how to use the IG Publisher. We're not going to do that in this session. So if you would like to participate in the hands-on session, there are multiple different ways on how you can do that, depending on your level of dedication you already have using FHIR Shorthand. If you're only here to find out what it's all about, and you're not even sure if you're actually going to use it after the session, you might not want to spend a lot of time installing stuff on your laptops, and that's perfectly okay. You can join the session using online tools only. But these online tools have a couple of disadvantages. I don't really recommend them for actual productive usage because it's very easy to lose your work. One click on the wrong link, one accidental closure of your browser, and you may lose all of the work you've done. So if you want to use FHIR Shorthand for real, you might want to get everything installed locally on your laptop. And you can do that right now, if you like. There's instruction on how to download and install Sushi and Visual Studio Code. If you want to do that, and you can do that during this session in the background, maybe even use the break time that we have, and then get started in the next session using the option number 1. Again, if you don't want to install anything, you can use either option 2 or option 3. Both are online tools. But they will not give you the full capabilities to configure your project, to configure the behavior of the Sushi compiler, but you will still be able to follow the exercises. What both of these options have in common is that it's easy to lose your code. So please make sure that whenever you've completed an exercise or you successfully created a FHIR resource, that you just copy and paste your code into a text editor just to be able to save it in case your browser, you accidentally close your browser or it's crashing or something like that. I will actually skip between the different tools and show you the results that they produce using the same FHIR shorthand code that we input. And you can switch tools anytime. If any of these tools stops working for you at any point in time during the session, just copy your code and paste it into the other tool, and you should be able to continue right away with any of the other options. I also have the information on this slide. I have copy and pasted this in advance into the Hoover chat for this session. So if you open the Hoover app and look at the chat of this particular session, you will find the links and you can click on them and install or access the tools that we have right here. Please note that for option number 3, you will actually need a Simplifier account. That's free. You can sign up for free on Simplifier if you don't already have one. But it will take a few moments because you will be sent an email and then you have to confirm your email until you can actually use your account. So that might also take a little bit of time to set up. Option number 2 is something that everyone will be able to use. You just open a web page and then you're ready to go. By the way, if you have any questions, we're not going to do a dedicated Q&A session. If you have any questions, please ask anytime, just by show of hand or speaking up. You can ask me questions anytime. If you have any problems using the tools or questions, please feel free to ask at any time. So the first option that you can use is basically the same way you would use any kind of programming language, because that's what FHIR Shorthand actually is. It's a programming language where you write code and then you use a compiler to transform this code not into an executable program, but instead into FHIR resources. So we need an editor where we can write our code, and we need a compiler that transforms our code into FHIR resource. And that's what sushi is. You may often have heard fish and sushi used in combination, sometimes even interchangeably. But what they actually are is that FHIR Shorthand of fish is the programming language, the specification of syntax and grammar for that language. And sushi is the compiler. Sushi stands for Sushi Unshortens Shorthand Instructions, I think, if I got it right. And that's basically the name of the compiler that runs through your code and builds FHIR resources from them. And again, you can either install Sushi locally and use Visual Studio Code, or basically any other kind of editor to actually write your code. I only recommend Visual Studio Code because there's this neat little FHIR Shorthand extension that you can install on top that will give you code highlighting and auto-completion and some very nice features that you would expect from a programming environment. But again, if for any reason you cannot install Visual Studio Code or you would prefer another editor, you can use any text editor out there. Notepad will do as much as anything else. Your Sushi compiler, if you compile a project, your compiler expects a certain structure within your project. You can first create a folder locally on your computer, and you can name that folder anything you like. Whatever you want to call your project, that's the name of your folder. And in that folder, you have to create a subfolder named input, and this is where all your FHIR Shorthand files will go. In that input folder, you have another subfolder called fish, FSH, and in this subfolder, you can put as many files as you like. The only thing that's important for these files, again, you can name them any way you want, but the important part is that the extension of these files needs to be .fsh. Any file that you put into that FSH folder and that has an FSH extension will be picked up by the compiler and transformed into FHIR resources. How you name your files and how you structure your files is completely up to you. You could basically write your whole project in one big fish file where you have like 5 examples and 10 profiles and 12 extensions. You can do that, but you could also create individual files for each and every instance of a FHIR resource that you create, or you might sort them by topic. For example, you have one profile with 5 extensions and 2 examples, and you might put them all into one file, but then for your next profile, you might use another file. Again, it's completely up to you. The compiler will ignore any structure that you have, and it will just take every line of code in any fish file as one big project and compile it. The other thing that we need is a configuration file that kind of configures the behavior of the Sushi compiler. And this file needs to be named exactly sushi-config.yaml. This file needs to exist for the compiler to run properly. And you need to put some very few configurations into this file. First of all, we're going to set the fish-only option to true. By using this option, we are basically deactivating the IG publisher part of this tool. Because if we want to use the IG publisher, we have to do a lot more configuration here, because we're also configuring the IG publisher. But we're not going to do that. We only want to run the Sushi compiler. So by setting fish only to true, we can save a lot of time setting up configuration that we're not actually using. The next option is we have to decide the root for the canonical URL that we are going to use. Whenever you create FHIR specifications like profiles, extensions, value sets, code systems, all of these artifacts will be named by a canonical that you choose. You choose to give a specific unique name to each and every one of these artifacts. However, in FHIR Shorthand, you don't have to do that manually. Instead, you define one root canonical that is the same for every artifact in your project, and then the compiler will automatically create the specific canonicals for each artifact from this root. So this is basically like a namespace, a common namespace for every artifact that you put into your project. And normally, your canonical namespace would be something like your company's domain /FHIR/name of the project. But again, it's totally up to you how you want to structure your canonicals. Just remember that this is the common namespace for all the canonical names that will be assigned by a Sushi compiler. If you use Sushi only and exclusively to create FHIR example data, like you want to create 15 patient resources and 20 conditions for some purpose, you're not going to actually use this canonical, because canonicals are only assigned to definitions, not to actual instances. However, you will have to put this configuration down, because otherwise the compiler will return an error. So you can just put example.org if you're not actually using it and you just want to silence the error from the compiler. And the third option that we need is we need to tell the compiler which version of FHIR we're going to use. So commonly, as we learned this morning, except if you're living in Estonia, you're probably going to use version R4, and the official version number of R4 is 4.0.1. So basically what you can do is you can just copy-paste what I have on my slides into the sushi config YAML file. You don't need the comments that I added for explanation. So you basically only need these 3 lines in your configuration file. There's also a sushi init command that automatically initiates a project and creates the file structure and the config file for you. However, this init function assumes that you're going to use sushi in combination with the IG publisher, and it will ask you a large number of questions to configure your project for the IG publisher. So it will create a way more complicated project than we need for our purposes. And that is why I prefer to do this by hand, to keep everything neat and tidy and only have the information in our project that we are actually going to need. If you're using the online tools, like options 2 and 3, you're not going to need to take care of the structure or to configure your compiler. In this case, you will only have a text field. Like, for example, this is the FHIR Online tool. It has 2 panels. And on the left side, you type in your FHIR Shorthand code. And then you press the Convert to JSON button at the top. And the compiler will run in the background. And it will return the FHIR resource it created as a JSON file and show it to you on the right-hand panel. You have some limited options to actually configure your compiler. If you press the configuration button, you can actually see the same configuration options that I showed you for the config YAML file. You can enter your canonical URL that you would like as a prefix for your canonicals. You can enter the FHIR version. And you can also add dependencies if you want to reuse contents from other specifications. That's something you can enter here. Of course, normally you would do that in your sushi-config.yaml file. If you use the third option, which is the FHIR playground that you can find on the starting page of Simplifier, it's very similar to the FHIR Online tool. Again, on the left-hand side, you have a panel where you can just type in your FHIR Shorthand code. Please be careful. This tool is read-only until you are logged in with a FHIR account. So if you find that you cannot edit the code on the left-hand side, you might have to sign in to Simplifier in order to be able to edit. And again, you type your code on the left-hand side. Then you press the green play button at the top. That, again, will run the compiler in the background. And other than with the FHIR Online tool, Simplifier will create a visual representation of the FHIR resource that you created, which is extremely helpful if you are using FHIR Shorthand to create profiles. Because in order to inspect a profile and to figure out whether it actually does what you intend to do, you're normally not looking at a JSON resource. Instead, you would like to look at the tree view of your profile. And this tool will actually create this tree view right away from the FHIR Shorthand file that you created. It also has other tabs, so you can also look at the output in JSON format, which will then show you exactly the same thing as the FHIR Online tool. But you can also look at the FHIR resource that has been created as an XML file. So if you are more inclined to read code in XML than in JSON, you might want to prefer this tool because it will give you XML output alternatively. However, with this tool, the danger of losing your work is the highest because there's no caching happening of what you are doing in this browser. And if you move over the output of your resource, you will find quite a lot of references. And whenever you accidentally click on one of them, you will have left the page, you will have left the tool. And if you go back to that page, you will always see this exact lines of code that are just there by default, and anything you entered into that box will be lost. So if you choose to use this tool, please make sure that you save your code every once in a while by just copying it into like an editor or something. Okay, so I'm going to assume that at least a few people in this room will use Sushi locally. So I'm going to go through the steps of creating a new folder. I have a dedicated profile directory, so here I'm going to create a new folder, and I will call it DevDays 2024 Fish Tutorial. Again, it doesn't really matter. You can name your folder anything you like. That's going to be the name of your project, of what you are going to do. In this folder, I'm going to create an input subfolder. And this is basically where I'm going to put all of my FHIR Shorthand files. Now let me just open this folder using Visual Studio Code. So let's see, there are my profiles. Here's my DevDays fish tutorial folder, and that's the one that I'm going to open right now. Okay, so now I can see my empty folder with my empty subfolder in Visual Studio, and I can now add my sushi-config.yaml file. And then, because I'm a lazy person, I will just copy and paste these three things. I will also put them in the chat. If you want to copy and paste as well, you don't have to kind of type everything out. I'll just remove my comments to keep it neat and tidy. There you are. And I will just put it here. And I will give this a nice domain. I'm using my company's domain, and I will give this also the name DevDays 2024 Fish. That's enough. Canonicals shouldn't be unnecessarily long, so that's going to be my namespace for the artifacts that I'm going to create within this and the next session. All right, so now I'm going to select the input folder and create my first fish file, which I'm just going to call exercise1.fsh. Again, what you choose to name your files is totally up to you. You could name them John and George if you like. Doesn't really matter. File names are completely ignored by the Sushi compiler. So, regardless of which tool you choose, we will all going to be writing the same FHIR Shorthand code. So whatever I type into my fish file, you would type the exact same thing into the left-hand panel of either the Simplifier online tool or the Fish online tool. So the grammar of FHIR Shorthand language is fairly simple. Whenever you create a FHIR resource or any artifact, it starts with a little header where you're basically telling the Sushi compiler what it is that you are intending to create. So in this header, we're going to, first of all, tell the compiler that we want to create an instance. instance. There you go. An instance of a FHIR resource. Because as first exercise, I want to create a patient resource, right? That's what we all do whenever we want to start anything with FHIR. First thing is we create a patient resource. So we're going to do the very same thing. And now I'm going to assign a name to that instance. Again, how I choose my name is completely up to me. It just has to be a machine-readable name, so it's not allowed to have any spaces or any special characters. I actually recommend that you just use camel case names. For example, my first patient. That's a nice name for this resource. And the second instruction that a compiler needs is it wants to know what it is that you want to create an instance from. So you basically have to say that you want to create an instance of a patient resource. And the keyword is instance of, and then you just type the name of the resource type that you use. In our case, it's a patient resource. So, and this is basically all the compiler needs to know in order to figure out what we want it to create for us. So this is the header. And now we can add instructions. And every instruction starts with a star. So you're basically kind of creating a bullet point list of things that you want the compiler to do for you. And the easiest kind of instruction that we can use is to assign values to fields. Especially when we create like example instances, like we do right now, we might want to give this patient a name and a birth date and a gender and an address, etc. And in order to do that, we first need to give the path of the element. Like, for example, if we want to give a patient a birth date, we have to write down the name of the element. And then we use an equal sign, and then we assign a value, for example, birth date. That would be the way we assign a birth date to a patient resource. Please make sure that you put spaces in front and after the equal sign, otherwise the compiler will throw an error. Other than that, that's pretty much the syntax to assign values to elements. Then, of course, we may have nested elements. For example, the name of a patient has subfields for given and family name, so we can simply write name.given if we want to assign a string where we need to use quotes. And this would be the way to assign a given name to our patient. Now, since a patient resource doesn't really have any required or mandatory elements, this should already create a valid FHIR resource, right? So we can already use our compiler and see what happens. If you're using the online tools, you're lucky now because all you have to do is press the button at the top of the page. In my case, I have to run the compiler from the command line by typing sushi and then give the path to my project, which I'm just going to copy from here. And please make sure that you use the path name of the top level folder of your project. Not the input folder, but the top level folder where you have the input folder and the sushi config file, because the compiler will always use this path and look particularly for the sushi config file. If it doesn't find it, it will return an error. Officially, the name of the command to run the sushi compiler is sushi-build. But the build command is also the default command. So if you don't put a command after sushi, it will automatically build your project. And again, I'm a lazy person, so if I don't have to write something out, I'm not doing it. So I just use the sushi command and a file, and that will actually start the compiler. And I have made an error. Oh, what's happening? No, I'm not going to update anything. What? Wait, that has changed?
Matches what you had in your earlier slide. Right.
Oh, I missed it. Yeah, you're right. Yeah. I missed the fish folder. Gosh. Yeah. I was just confused. Yeah, I should do what I say. Not say one thing and do something else. That usually never works. Okay, so if you run your compiler for the very first time, it might take a while to finish, because if you're running it for the very first time, it will start downloading the FHIR version. Like if you entered that you want to create a project on FHIR R4, it will now download the R4 specification files, and that might actually take a while. If you're running it consecutively, it will finish a lot faster. In my case, you see it's only a few seconds for it to run. And if sushi terminated successfully, you will see this green box that will give you the number of files, a number of resources it created. And you can see in my case, it has created one instance of a FHIR resource, which is expected because that's exactly the instructions that we had. If your fish files contain a syntax error, this box will be red, and you will have a number of error given. And then if you scroll up, where right now I have all of these green info lines, you will see an error in between, and that will give you information about which line in which file had a syntactical error, for example. By the way, if you are using Fish Online instead, of course you will have typed the exact same code. You would have pressed the Convert to JSON button in order to start the compiler. And you can actually see the same output that I had in my command line if you expand this console at the bottom, and you will see the exact same results. If your compiler returns an error, the console will automatically pop up. If it's successful, you will not see it unless you explicitly pull up the console. But if there's an error in your code, like if you're, for example, missing a space, the console will automatically pop up and show you the problems that it encountered. And here you can now see what it looks like if you have an error. Then it will tell you that the element or path birth date equals does not exist in line 3. So you can go to the line and then correct your mistake and just run sushi again. We have another 10 minutes, right? Yeah, okay, awesome. All right. So, the next thing that we can do, we can also assign a gender to our patient. However, the first thing that we assigned was a date. The second thing we assigned was a string where we have double quotes. And now we're going to assign a code. And whenever you assign a code, there's a special syntax for that, which is you use a hashtag and then the code female, for example. By putting a hashtag in front of your code, this is kind of an indication to the compiler that this is not a string, but instead this is a coded value that you want to assign. Again, we can simply run the compiler either locally or in Sushi Online, Fish Online, and then you will see that now we have a patient resource with a name, a birth date, and a gender. You may have noticed that the Sushi compiler automatically uses the name that you gave to your instance as an ID for the resource it creates. That's just something that's happening automatically in the background. If you want your instance to have another ID than the name that you gave to this artifact, you can just manually assign an ID. So if you want to have, like, for example, a numeric ID, you can simply put it in. And then this will override the default and put the ID that you chose. Or maybe not. What am I doing wrong? Oh, it's a string. IDs are strings. Yeah, so I should quote them. Yeah. So if you don't do anything, it will automatically use whatever you put as name for the instance. Again, if you want to temporarily deactivate lines of code, you simply put 2 dashes in front of the line, and then the compiler will ignore that line. Or you can just maybe put a comment at the end of the line, which is helpful to, add comments to your code, which we can actually do because this is what you're going to take home from this exercise. So if you want to later reproduce what we did in that session, feel free to add lines of comments to explain what it is we've been doing. Okay, next I'm going to add a family name to my patient. So normally I would have, again, to type out the path name.family this time, which will work as expected and assign a family name to that patient. However, I'm a lazy person. I don't know if I already mentioned that I'm a lazy person and I don't like to type stuff redundantly. So you can alternatively use indentations. So you could instead, and that will give you this exact same result, you could write name and then use 2 spaces for the next instruction, and that will interpret the path that you use as a relative path to the path you had in the line above. So this way, we don't have to type name twice, and we can instead just use the indentation rule. Again, use 2 spaces for indentation. That's very important. It has to be no more and no less than 2 spaces for this to work properly. And that will have the exact same effect. The path given a family will be interpreted as relative path on the name element of the patient. It's not really saving a lot of time in this particular example, but imagine you're giving an address to your patient, and you have to use line and postal code and a street number and whatnot, and you have multiple lines that all start with address, point, something, then you're saving actually a lot of time writing it out that way. And also your code will be way more readable if you use indentations, because then the structure of your code kind of looks like the structure of the resource that you are building.
Question.
Yes?
Nest it then too? So like if it was...
Yeah.
So
it can even go deeper than that. Yeah, if your field element has another subfield, you can have multiple levels of indentation. Yeah. Speaking of structure, you don't have to pay any attention whatsoever to the sequence of the elements. You can see that now I already mixed them up. If you look at the FHIR specification, the name will be before the birth date, but I put the birth date before the name. The FHIR compiler will not mind if you jumble up the sequence of elements. So you could put any sequence if you like, but the indentation, of course, has to be appropriate to the structure of the resource. Yes?
Is there a place specific, or is it just FHIR, like the FHIR website, where it shows a given structure, for example, like an address, how to format that correctly? Is that trying to just put a string in there into an error?
Yep. The question is, where do you see the appropriate structure? And yes, you already gave the correct answer. You look at the spec. So, whenever you create an instance of a resource, I would recommend that you have a tab open with the resource type. In our case, it's a patient. I'm now looking at an R5 patient, but since the patient hasn't really significantly changed, we might as well look at that. And that will tell you the structure. This is where you take the names of the elements that you can use in FHIR Shorthand. And then you can, for example, if you want to add an address to your patient, then you know that the path name is address. And if you want to know the structure of that path, you can follow the link to the data type, and then you will see the subfields that you can use to populate the address, like line and city and district and state and whatnot. Okay, the last 3 minutes of this session, I'm going to introduce you to one more secrets of the behavior of the FHIR, of the Sushi compiler, and that has to do with repeatable elements. While a patient only has one birth date and one gender, a patient can have multiple names, and he can actually have multiple given names within one name. And whenever we write it like that, this implicitly means for the Sushi compiler that we mean the first given name in the first name element of that patient. So if we wanted to give our patient multiple names, or let's say multiple given names, and add another one, which is allowed because the cardinality for name.given is 0 to star. But you will see that whenever I put something else in another given name, the compiler will just override the first name, and you'll only have the second given name. So it doesn't actually create multiple given names, even though I instructed it to do, because it implicitly interprets each of these names, of these given names, to mean the first given name of that resource. If we want to explicitly say that our patient has multiple given names, we have to add indices. So, for example, we can explicitly say that this is the first, or in IT speak, the 0th name, and then this one is the first given element, and then it will actually create multiple given names. But we have to explicitly say that these are distinct names by using an index at the end of the path. And then now you can see we have 2 given names in our patient. The same is true if you have multiple names. Again, then you will have to explicitly add an index for each and every occurrence of a name for the compiler to interpret it correctly. If you have items that repeat not once or twice, but maybe 10 times, 30 times, because you have like a questionnaire with dozens of items, you might not want to make your index explicit, because every time you insert a new item in between or you rearrange your items, you will have to re-index everything. So in that case, it will be easier for you to use what we call a soft index, where you basically just tell it to increment the index by 1, and that will, again, have the same result. But now if you were to add another given name in between or change the sequence of the given names, you won't have to rewrite the indexes. The indices you can basically flip around the stuff right now without changing it. All right, so that's it for the first session. If you want to use the break to install and set up your local file, I will stick around to help you if you have any issues. If not, you can just continue with the online tools in the second session as well. That's perfectly fine. And with the knowledge that you have from this very first session, how to create an instance of the FHIR resource, you basically already know everything you need to know. You could create, in the same method, an instance of any FHIR resource, right? You could even create a profile, because what is a profile other than an instance of a structure definition? But there are many tricks on how to make this way easier than actually creating an instance of a structure definition, and that's what we're going to talk about in the next session. And we will build on top of that. We're going to create a profile of a patient. We're going to create extensions, value sets. Depending on how far we get with time, we're going to walk you through all the different kinds of resources that you can create with FHIR Shorthand. Thank you, and enjoy your break.